Hello everyone, welcome to today's webinar. Today we will go over the first section of Unit 2 in Algebra 1 course. This course is about inequalities and equations. Today we will speak only about equations. Also in this unit there is a section about solving system of equations, which is advanced equation solving that we will go over together in a second webinar that serves that unit. And also a third webinar will be dedicated for inequalities. Today we will go over equations together. This is myself. My name is Miriam. I'm your math instructor at Penn Foster. I'm certified to teach high school math in the state of Pennsylvania. I also have my master's in education. And today we will go over the most challenging topics in this unit, and specifically the first section of this unit that deals with equations. During this webinar, we will go over the different kind and different level of difficulty in equations in one variable, and also we're going to follow that by a self-check question. Those questions are not graded. These are there in the webinar to give you a chance to assess yourself if you need help in that topic or that level of difficulty in this section of the unit, or you feel okay, you feel understanding everything, then you can move forward and read the next section in your unit. So those questions are merely for your benefit, so I would appreciate if you participate in those questions. You are able to ask your questions and type them in the questions box. The raise your hand feature does not work in our webinars. Also, all registrants for this webinar will receive a recorded webinar to watch at their convenience. In this webinar, we specifically will go over different methods of solving equations with one variables. Those methods are either to add or subtract, multiply or divide, and also we will look at equations that has variables on both sides and how would we change that equation a little bit so we're able to solve that, and also we will see equations with signs of inclusion. So I thought to start with giving you an overview of what is an equation. An equation really, it is a state of balance. So I thought to bring the jigsaw. So I would demonstrate the idea of equations using the jigsaw that you see on the screen now. This system is balanced already. If you look on the left-hand side, you will see that there are some balls there. On the right-hand side, there are a bunch of other balls. But this system seems that the weight of the balls on the left-hand side is the same weight as the balls on the right-hand side, and that what keeps the jigsaw balanced. So this system, we can think about it as an equation. We can think about that as an equation in terms of the colors of the balls. So if I'm gonna think about the red ball as being the x, the variable, and the blue balls would be just numbers. So let's represent this system or figure using equations, using algebra. So if I want to write an equation, we said the ball is an x, so we have one x, so it is an x, and also added to that we have three balls, and we said the blue balls are just numbers, so x plus 3 equals to, because the system is balanced, equals to 1, 2, 3, 4, 5 on the right hand side. So x plus 3 equals to 5. Now, our job always in algebra is to isolate the variable here, this variable, the red ball, to be on one side. Typically, it's the left side. If you put your variable on the right side, it's not gonna be a big deal. It just, it is a habit that we write the variable on the left side. So our job, our goal in any kind of equation that you have, or even inequalities when we go to the last webinar and see that together, is to isolate the variable, the red ball, on the left-hand side, and everything else should go to the right-hand side. The only condition is that we need to keep that system balanced. And to do that, we have to follow certain rules. Now, let's say that we took off those 3 balls from the left-hand side. If that happens, then this is what's going to happen. What's going to happen is that the system will lose its balance. Now, this side, the left side, is so lighter than the right side. We need really to know how many blue balls is equivalent, or the weight of how many blue balls is equivalent to the weight of 1 red ball. And to do that and to keep the system balanced and answer our question, we actually took 3 balls from the left-hand side that was not good enough. Then we need also to do the same thing on the other side. Take away 3 blue balls from the right-hand side. If you do that, then you will come up again with a balanced system. And having the red ball on the left-hand side alone, and then 2 balls on the other side, it is like saying that 1 ball, the weight of 1 red ball actually equals to the weight of 2 blue balls. So x equals to 2. And that is the solution that we are looking for in any algebra equation. We're looking for a variable on the left equals to 1 number, and that would be our solution. So what did we do actually is we used algebra to find out the answer x equals 2. What we did actually is we subtracted 3 from the left-hand side of the equation, and we did the same exact thing for the right-hand side of the equation. That kept our system balanced. So if you do that, 3 minus 3 is a 0, so you're left out with an x on this side, equals to 5 minus 3 is a 2. And that's how we got our answer. This is only a visual representation of how equations work and why do we have to do the same thing on the left-hand side and the right-hand side to keep our equation balanced. Let's get into the real algebra. Now, you will see those kind of equations in your study units, in the examples or the practice questions, or discover more questions. To do that, we're not going to draw a jigsaw or anything. We need really to follow certain rules to arrive to the sole goal of solving equations, which is isolating the variable on the left-hand side. So the goal is to isolate the variable on one side, typically the left-hand side, and bring all the values to the other side. This is our goal. So as we did in the previous slide, we're going to follow the same steps. We're going to undo whatever is done to our variable. What we see here in question 1, let's read the equation. Y minus 22 equals to 105. I need to isolate my variable. I need it by itself on the left-hand side. I see a minus 22. Let's undo the subtraction of 22. The opposite of subtraction is addition, so let's add 22. So add 22 on the left-hand side, but you need to do the same thing for the right-hand side. Remember, we have to keep it balanced, so it stays an equation. And then add 22 to the 105. Now you just do simple math. Minus 22 plus 22 is a 0, so that is gone. You have a y by itself on the left-hand side, and then just add those numbers. 105 plus 22 is actually 127. Your answer is this. How did I know that this is my answer? Well, since I have a variable by itself on the left-hand side and an equal sign and a number by the right-hand side, this is the end of my solution. This is my answer. If you have questions, if you have just joined the webinars, the raise your hand feature does not work, but you can ask your questions by typing your questions in the questions box. Let's do number 2. 23 plus x, and x is here the variable, equals to 20. What is x? What is the value of x? Remember, the goal is to isolate the x. So undo any operations that's done to our variable to arrive to our goal. Now 23 is added, and 23 is added not because of this plus sign, but because this number is a positive number. So our variable was added to 23. The opposite is subtract 23. So subtract 23 and subtract 23 and do the math. 23 minus 23, of course, is a 0, so we have x by itself on the left-hand side. And now we have to subtract 20 minus 23, which will give you a negative value, -3, which is okay. Our variable can have a decimal answer, a negative answer, a fraction answer, a positive answer. Whatever the answer is, if you followed the steps correctly, then that would be the answer or the value of your variable. Any questions so far? Anything that's not clear? You need to remember that algebra is kind of a language that we need to learn the grammar for, the rules, the steps, the order of those steps, and also we have to practice. With any language, you have to practice the language to acquire that language and be able to speak that language. The same thing with algebra. It may be tough in the beginning, it may be confusing in the beginning, but if you follow the rules correctly, if you practice enough, it will become kind of a second nature. When you see an equation, you know right away what to do or where you should start from. Let's do number 3, and we see some decimals in our equations. We should not panic if you see something weird in the equation, like a fraction or a decimal or negative numbers. We're going to follow the same rules. So we have a negative 0.75 plus the variable z equals to 1.58. Now, this variable has a subtraction, and I said subtraction because this number has a negative sign. So to undo that, I need to add the same value, plus 0.75. I need to do the same exact thing to the other side to keep it balanced, to keep it an equation, to keep it true. So negative of the value plus the value itself, it's just nothing, 0. And then you have a z on the side, on the left-hand side, and then you can use your calculator actually to add these two decimals. We're not learning how to add decimals manually, so it is okay to use your calculator at this point. When you add those two decimals, you will have the final answer. 2.33 is the value of your variable. Next, let's work on another two examples. 50 equals to 25 plus x. The special thing in this equation is the x does not appear on the left-hand side anymore. We see it on the right-hand side. It is okay to have the variable on either side. So we're going to follow the same steps. Now this x was added to 25, so subtract 25 from both sides. Minus 25 and minus 25. Do the math. 50 minus 25 is 25, equals to, that will go, it's a 0, and then equals to x. Now this answer says 25 equals to x. It's the same as saying x equals to 25. We just have used to write the variable on the left-hand side, but if you kept your answer as this, having the variable on the right-hand side, your answer is still true. Last equation that we have, u minus 100 equals to 31. Well, the u was subtracted here, and the 100 was subtracted from the u, so reverse that, add 100, and add 100. Then that will become a 0. U by itself equals to, add 31 plus 100 is 131, and that would be your final answer. Let's look at a self-check question. Simple equation, the same kind of equations that we have been doing since the beginning of the webinar. We need to undo the operation that's done to our variable to isolate the variable. I'm going to keep my screen on for a while, for about 30 seconds. You can have a look at the equation, grab a pen and paper, write the equation, try to solve the equation, and then at the end of the 30 seconds, I'm going to switch my screen to the same question, it's just a different interface, so you're able to actually click to the on the right answer and submit your answer that you think is true. I'm not going to judge you if you did get that answer incorrect. This is only for you just to see if you have good understanding of this topic, and it's also for myself to see if I've done a good job explaining this topic. So here's the equation. You're going to follow the same rules, and you have 4 options. Which one is the right value for x? Okay, so I'm going to switch my screen to show you the same question, and this time you're able to choose your answer. Okay, I'm going to share my final answers on those questions. So when you get the recording, you're able to pause the video and work on those questions. Even have a chance to work on those questions now and compare answers. If you happen to have questions on those self-check questions within the webinar, you're able to email the instructor those handouts that you see, and you're able to download as we speak. One of them shows you in details how would you go to your portal and send an email to your instructor. So the value of x, the correct value of x is B. X equals to 819. Let's go to another kind of equations. In these sets of equations, we do not see additions or subtractions that we can undo. We actually see multiplication and division. How would we solve an equation that we have a number multiplied to our variable or a variable divided by a number? The same kind of idea. Well, we have to do the opposite operation. The opposite of multiplying a variable times a number is divide the variable over that number. So 6 times x equals to 72. That let me divide over 6 and do the same exact thing on the other side, divide over 6. So 6 over 6 is a 1. In algebra, we do not write the 1, so actually we will end up with an x. It's 1x, but we just write it as x equals to divide 72 over 6 will give you the value of x, which is 12. And that's your final answer. Okay, let's do the next question. U divided by 36 equals to 5. What is the value of U? The same thing, the same rule that we have been following since the beginning of the webinar. Do the opposite of the operation. The operation that we see in our equation is a division. Then the opposite would be multiply. Multiply times the denominator. So multiply this u over 36, which is actually a fraction, times 36. Do the same thing for the other side, times 36. We know that those 36 will just cancel out to be a 1. So we have u equals to, and then multiply 5 times 36 will give you 180. So u equals to 180. If you have just joined us in the webinar, you are able to ask questions even during the webinar. You can ask the questions by type them in the questions box, and I'll be able to see the question and who asked the question as well. If it relates to what we do at the moment, I'm going to go ahead and answer that right away. If it's a general question or something from the past slides, I can go back to them at the end of the webinar if we have enough time to do that. The third one, I see decimals in our equation. I'm not going to panic. I'm going to use the same rules. It's a decimal number times x equals to another decimal value. Divide on that number that's multiplied to the x because I'm trying to undo the multiplication. Divide over 8.1 and divide over 8.1. As I said before, when you divide those decimals, you do not have to use the calculator because, again, we are not learning how to divide decimals using long division. We are learning algebra. So 8.1 over itself is a 1. So we're going to have an x on the left-hand side. Use your calculator and divide those two decimals, and the answer would be 0.66. Any questions? Anything that was not clear or did not make sense or did not match what you've read already in your lesson? Okay, let's move on to the next questions. Okay, the same kind of things. We have division. U divided by a negative 50 equals to 100. We need to be careful when we have negatives in multiplications and divisions because you know that a negative times a negative is a positive. You know that a negative times a positive or a positive times a negative will give you a negative answer. The same thing with division. When you divide, you need to be careful of the signs. So let's see how would we handle that having a negative in the denominator here. The same rule, undo the division. So multiply times the denominator. Multiply times negative 50 and multiply times negative 50. Now, negative 50 over itself is just a 1, a positive 1. A negative over a negative is a positive. So we have a u on the left-hand side. Now we need to multiply 10 times negative 50. A positive times a negative will give you a negative answer, and it's going to be negative 500. And that is the value of u. Same thing with number 4. U divided by a negative 2 equals to a negative 1. We need to be careful. The same thing. Undo the division, multiply times a negative 2. Do the same thing on the right-hand side. Negative 2 and negative 2 will just cancel out to a 1. U equals to a negative 1 times a negative 2 will give you a positive 2. U equals to positive 2. Last question, 10x equals to 270. So 10 here is multiplied, do the reverse, so divide over 10. And don't forget to do the same thing on the right-hand side because we need our equation to stay balanced. So 10 over 10 is, of course, is a 1. X equals to 270 over 10. Without the calculator, those zeros will just cancel out and your answer will be at 27. And x equals to 27. Questions? As I said in the beginning of the webinar, you will receive a recording of this webinar whether you attend or you didn't have to attend. As long as you have registered, you will receive a recording in the follow-up email. Also, attached to this webinar, you are able actually to look at the handouts that have attached to this webinar. 3 of them you're able to look at, and even students who had not had the chance to attend will have an access to those handouts as well. Now let's look at a self-check. Those self-checks, as I said, are not graded. These are for your assessment, self-assessment. So it's an equation, the same thing that we have been doing in the past few slides. Y divided by a 10 equals to a negative 90. What should we do to find the value of y? So you can have a look at this question in 30 seconds. I'm going to switch the screen to the same question, but you are able to select your answers. Okay, I'm going to switch my screen to give you the chance to enter your answers, and also gives me a chance also to assess my instruction. Okay, I see that some of you have decided to enter their answers, and it's so far correct. Good job. Even if you have selected the incorrect answer, it's okay. Don't get discouraged. We're still learning. It's a learning curve. So it's not the end of the world if you have that question incorrect. So let's, I'm going to share my final answer. So when you get the recording, you will know at least the final answer is negative 900. C. Next. Okay, what if we have an equation that has multiple operations? So we have addition and we have multiplication. Which one should we undo first? And by the way, those notes on the right hand side of my slide, they summarize the rules. If you keep like a notebook to your studies, you are able to write those notes on the margins of your pages, or if you print out the study units, or have a special kind of note-taking process that you keep, or a notebook, as I said, you're able to write those notes, and I prefer a summary of things. So when I do the exam, when I do a practice question, I don't have to go to the huge unit or the lesson and go back and forth just to look up one rule. So that way it's handy and it is convenient. So what should we do first? Should we undo the multiplication or should we undo the addition? Well, we're going to undo the addition and subtraction first, and then if division or multiplication exist in the same equation, then we undo them next. So we have to subtract 12 and subtract 12. At this point, we have negative 3a will be the same, negative 3a. Now 12 minus 12 is a 0, so that's gone, equals to 72 minus 12 is 60. I'm not done yet because I have my variable still multiplied to a number. My goal, remember, from the beginning of the easiest kinds of equations is to isolate the variable by itself on the left-hand side, and everything else should go to the right-hand side. So I'm not done yet. I have negative 3 times a, then divide over negative 3 and divide over negative 3. Negative 3 over negative 3 is a 1, so a equals to 60 divided by negative 3 will give you a negative answer, and it's negative 20. And that's your answer. Why this is it for us? We have the variable by itself on one side, everything else, or just one value on the other side, and that is the solution of the equation. Number 2, we have b over negative 2 minus 3 equals to negative 8. Remember, we have to undo addition or subtraction first, and then deal with division or multiplication. So I see subtraction. Let's undo the subtraction. Add 3 and add 3. So far we have b over negative 2, that's gone, that's a 0, equals to negative 8 plus 3 will give you negative 5. I'm not done yet B is not by itself. I see B over -2. Reverse the division by multiplying times the denominator times -2 and times -2. These will cancel out to be a 1. So B equals 2, and then multiply -5 times -2 is positive 10. And your answer is 10. So again, with these kind of equations, where you have mixed operations in one equation, undo addition subtractions first, and then deal with divisions and multiplications next. Okay, let's look at the next questions. The same kind of equation. 6 plus 3v equals to 27. The same rule. Get rid of the addition first. As I said, the 6 here is added because the 6 is positive, not because of this sign is a plus sign. If this sign was a negative sign and 6 still positive, we say that the 6 is added to the 3v, and in this case, to undo that, I need to subtract and subtract. Okay, so 6 minus 6, of course, is a 0. I have 3v equals to 27 minus 6 will give you 21. Final step is divide to undo multiplication and divide, then v equals to 7. That's it. Let's look at 4. Now, the variable exists on the right-hand side of the equation, which is not typical, but it's not going to change anything that we have to do to solve the equation. We have division and we have addition. Then we need to get rid of the addition first, subtract. -3 or -3 and -3. 26 minus 3 will give you 23 equals to b over 9, and 3 minus 3 is a 0. We still have b divided by 9, then reverse that by multiplying times 9 and multiplying times 9. 9 times 23 will give you 207 equals to, these will cancel out and it will just remain a b on the right hand side. We are used to write the variable by itself on the left hand side, so I'm going to rewrite my answer as b equals to 207, but if you kept it this way, it's correct. Okay, a self-check question. The same idea. We have two mixed operations. Which one should we get rid of first? So I'm going to keep my screen, and you can have about 30 seconds to do that before I switch my screen to where you can select your answers. Okay, and here's the question again, and the answers, choices, and you can select your answer. Okay, thank you for choosing your answers. So the final answer, the right answer, just for your reference, so if you choose to do those questions one more time, is B. B is the value, the correct value of Y. Let's move on to another kind of equations in one variable. Now, what if the variable itself appears more than one in the equation, what should we do? Do we have to solve twice, or what should we do? Remember from the webinars on Unit 1, we spoke about monomials. And actually 4v and a v both are monomials. When we added monomials, we just combined them and added the numbers in front of each variables because this variable is identical to that variable. It's a v and a v. So when we have an equation like that, you see the same variable more than one, combine the monomials, add or subtract those terms so you can see the variable appears only once in the equation. So I have 4v plus 1v. 4 and 1 is 5v equals to 45. Now it's a simple equation. We know exactly what to do. Undo the 5, multiply to v, divide over 5, and divide over 5. Now v equals to simply 9. That's it. So the only trick or only extra step that we had to do is just combine those like terms. Number 2, 250 equals to 2t minus 4t plus 8. Two things special in this equation. The variables appear on the right-hand side, which is not going to make a difference, just looks weird. The t appears twice in our equation, so we have to combine them into one variable. So 250 equals to 2 minus 4 is negative 2t and then plus 8. Now my variable t appears once only in my equation. I know how to do that. We have mixed operations. We have multiplication and addition. We learned that we get rid of addition first, so subtract 8 and subtract 8. 250 minus 8 will give you 242 on the left-hand side, and then the negative 2t will just remain, and that would be a 0 here, 8 and negative 8. Now I have one more step to do, divide over negative 2 and divide over negative 2. And be careful, a positive divided by a negative is a negative. So actually 242 divided by a negative 2 is negative 121 equals to t. Or I can rewrite it in the way that we used to write our answers, t equals to negative 121. That's it. Questions? Anything that's not clear or you're not sure how did we get to that step or those numbers? Okay, let's move on to the next kind of equations that we may see in our exam or practice questions or within the unit. Now 33y plus 4 equals to 3y minus 6. Now there is something special more about the equation, is that not only y appears twice, but one of the y's appears on the left-hand side, the other y appears on the right-hand side. What should we do to solve the equation? So the first step, I need to combine like terms. And to do that, I need to bring this 3y over to the left-hand side of the equation and then combine the like terms. How can I do that? Well, to move anything from left to right or right to left, you have to undo an operation. So to do that, I need to subtract 3y and do the same thing for the other side. Remember? Minus 3y. And then that will shift the 3y over to the left-hand side. 33y minus 3y is obviously 30y, and I still have my plus 4 equals to, that's gone, that's a 0. And then negative 6, that's a minus 6. Don't forget this is the sign of the 6, negative 6. Okay, that looks familiar now. So all I have is the variable appearing once. I have mixed operations. I have addition. Get rid of addition first. So subtract 4 and subtract 4. So that will be 30y that's gone equals to negative 10. I'm not done yet because my y is still multiplied to a value. I need to get rid of this 30. So let's rewrite the last line that we have. Okay, over 30 and over 30. Now y equals to a value. Negative 10 over 30 is negative 1 over 3, a fraction. So when you see a fraction as your answer, do not panic. If you do every single step correctly in the right order and you happen to have a fraction or a decimal answer, then that's your answer. Okay, let's do number 2. 215r plus 21 equals to negative r plus 12. What should we do? So I'm not going to get rid of addition or multiplications yet. I need to bring that negative r to here so we can combine the r's together. To do that, do the opposite operation. It's a negative r, then add r and add r. And when you add r, you're actually adding 1r. Okay, so 215r plus 1r, that will be 216r plus 21 as is equals to, that's gone, 12. And 12 because here is a plus, so 12 here is a positive number. So what I have here is actually an equation with two mixed operations. I have multiplication and addition. So get rid of addition first, minus 21 and minus 21. So I have 216r, that's gone, equals to 12 minus 21 is a negative 9. I'm not done yet. I have number times my variable, then reverse, divide over that number and divide. Okay, that's a 1. So far we have r equals to negative 9 over 216. You can use your calculator. It will give you a decimal answer, which is going to be a negative answer as well, negative 0.042. Or you can represent that in terms of fractions if you want and say, well, r equals to negative 1 over 24. Both answers are correct. Questions? Anything that's not clear in those two examples? So as you see, as we go over many different levels of solving equations, we're adding on steps to our solution depending on what we have in our equation. If it's a simple operation, just one operation, our variable is added to a number, then just subtract the number. If we have two operations, then we have two steps. Get rid of addition or subtraction first, and then get rid of multiplication or division next. If you have two variables, then you have to combine them. If you have two variables on different sides, then you have to add on another step. Bring in that variable next to the other variable, combine the variables, and then get rid of addition, subtraction, and then get rid of the multiplication, division. So see, you are building up on steps depending on how complicated your equation is. And how would you know where to start the equation? That will come by practice. As I said, whenever you practice more, as soon as you see the equation, you will know where to start. Okay, let's go to another kind of equations here. And the special thing here in this equation is that we have inclusion symbols or symbols of inclusion. And what we mean by that is the parentheses and the brackets. These are inclusion symbols that tells you to do them first. We have the upper priority of doing them first before addition or multiplication or anything like that. So this equation reads v plus 8 equals 2, and then I have square brackets, and then I have parentheses, 3v plus 4 minus v, and then minus 2, close the brackets, plus 4. Where should we start? We start by dealing with the symbols of inclusion, and we're going to go and work from inside out, meaning that we have to work and undo the parentheses first because they are inside the brackets. Once done with that, we're gonna look for the brackets and undo them, and then everything will become simpler. Let's start. So the left-hand side doesn't have any signs of inclusion, so it's gonna be the same thing, v plus 8 equals 2. Parentheses will be done first. So inside those parentheses, I have 3v and a minus v. These are like terms, then combine them. So I still have my brackets, but I'm working on my parentheses. So 3v minus v, it's going to be 2v. So I have 2v. And plus 4, so it stays the same, nothing to combine that with. I'm done with my parentheses. Now I can just delete them and not write them anymore because I just have evaluated whatever inside those parentheses. I simplified that. And then I have a minus 2, close the brackets, and I still have a plus 4 at the outside. Next, I need to deal with the brackets. So again, the left-hand side the same, equals 2. We have 2v plus 4 minus 2. Well, 4 and minus 2, we can combine them. They are just numbers. So I have 2v plus 2 and then plus 4, this 4 here. Next, everything is becoming simpler. So I still have v plus 8 on the left-hand side. I have 2v, but I have two numbers that I'm able to add them. So plus 6. Now, I'm going back to the last kind of equations that we spoke about. We have my variable appearing once on the left-hand side and once on the right-hand side. Bring that variable over to this side. So subtract 2v and subtract 2v. So v minus 2v will give you 1v, but it's going to be a negative v. So it's going to be negative v, negative 1v, plus 8 equals 2. That's gone. That's a 0. Equals to 6. I'm going to change my color, so I'm going to write on the side here. So I am finishing the work here. So far I have a negative v plus 8 equals to 6. That's very simple. Now, negative v, meaning that v is multiplied times a negative 1. So in this equation, I have two operations, addition and multiplication. Get rid of addition first, minus 8 and minus 8. So negative v will stay the same. And then you have a 6 minus 8 will give you a negative 2. I'm not done yet. I have a negative 1 times v, then reverse the operation. So divide over a negative 1 and divide over a negative 1. So v equals to 2. And that's your final answer. And that's your final answer here. So too many steps that we had to do to solve the equation because we had too many complications in the equation. We had symbols of inclusion, we had variables appearing in two different sides of the equation. We had to get rid of addition and multiplication. So for those of you who have just joined us the webinar, the raise your hand feature does not work. If you have a specific question, you can type in your question in the questions box. Let's do number 2. So no matter how complicated the equation may look like, we are just going to follow the same rules. So don't get distracted of how many parentheses that we have in our equation. We need to focus really on where to start and how would we perform the steps in the right order. So let's start. Okay, Kenny wants to do the question, I would believe question number 1 again. So let me see how much time we have. Let me do question 2. It's very similar to question 1. And actually those two questions comes directly from your study unit, and the answers for these are provided, so you're able to go back to the answer key. But if I have time, I will go over question number 1 for you, Kenny, and I'm sure everyone have questions on those, advanced types of equations. Thank you. Okay, so 4 plus 18d equals 2. I have brackets. I have 4 plus 3 times, and then parentheses, 2d minus 2. Okay, so we said we need to focus on the symbols of inclusion first. We're going to start from inside out. Inside out meaning that we have to handle the parentheses first and then the brackets. Now, our parentheses here have an expression. It's a binomial multiplied times a 3. So to get rid of the parentheses, I have to distribute the 3 over each term of this binomial. So I'm gonna rewrite the left-hand side the same because there is nothing to handle right now for that. So 18d, I need to make my handwriting clear so we don't get confused later, equals 2. I still have my brackets, 4 plus, now I am handling the multiplication. 3 times 2 is 6d. 3 times negative 2 is minus or negative 6, and I still have my square brackets or brackets. Now I need to deal with the brackets. I'm going to rewrite the equation from the left the same to the right. Now I have 4 plus 6d minus 6. I noticed that there is like terms. 4 and minus 6 are just numbers, so just combine them. 4 minus 6 is negative 2, and 6d will just stay. Okay, next, I see that I have two variables. Both of them are d, but one on the left and one on the right-hand side. So the next step, I need to bring this variable over to the left-hand side, subtract 6d and subtract 6d. 4 will stay the same. 18 minus 6 will give you 12d equals 2. I have a minus or negative 2, and these are just a 0. I'm getting here, everything is getting simpler. Okay, well, I have now an equation. I have two operations, multiplication and addition. What should I do first? What should I undo first? I'm going to undo the addition. So I'm going to finish my work out here on this side. Let's rewrite the last line. 4 plus 12d equals to negative 2. We said subtract 4 and subtract 4. 4 minus 4 is a 0. So on this side, I have 12d by itself equals to negative 2 minus 4 is a negative 6. Now I have the multiplication to get rid of, divide over 12 and divide over 12. So d equals to negative 1 over 2. That's it, and that's your answer. Again, your answer is a fraction. If that's the answer, then that's it. Any questions? Okay, so I would believe that this is the last thing I have to go over. I mean, before the self-check. Let's do the self-check first, and then if we have enough time, I can go back to question 1 and redo that again. So the self-check is the same kind of questions. We have inclusion signs, multiple operations, variables appearing in different sides of the equations, where to start. So here's the screen, start working on the problem, and then after about 30 seconds, I'm going to change my screen so you are able to choose your answers. Okay, I'm going to give you the question, and you're able to select your answers, the same question. Here you go. Okay, thank you for taking the time to choose your answer, and I'm going to give out the right answer. And the correct answer, the correct value for x is -3. And I'm going to go over this question actually because it goes on to the topic that some of you want to see. So I have symbols of inclusion. I need to deal with them first. I have this expression inside the parenthesis, but this expression is multiplied times 2, so I need to distribute the 2 over 4x and over 1. So this is going to be our first step. So I'm going to rewrite the question here, so I have much space to do that. So it's 2 times 4x plus 1. I'm just rewriting the same question so I'm able to see here clearly. So 2 times 4 is 8x. 2 times 1 is 2 equals to 7x minus 1. Now, all I have is two variables on different sides of the equation. Bring that variable, the 7x, over to the left-hand side. So subtract 7x and subtract 7x. 8 minus 7 is just 1x, which we write in algebra as x plus 2 equals 2. That's a 0, and then minus 1, or -1. Now, it's very simple. X is not multiplied times anything except a 1. So we just subtract and subtract, and x equals 2. That's gone, of course, and -1 minus 2 is a -3. So that's why x equals to -3. Okay, we have about 4 minutes. So can you let me know if you need me to go over that question from the previous slide? This one. You can type yes or no if that self-check has explained the thing that you weren't sure about. So Kenny, do you want me to go over that one question? Okay, well, everyone will get the recorded webinar as a follow-up email. So you can pause the video at each step that we do together here and just know why did we do that step before that step, or why do we have those numbers that we have in each step. So that way you have a way to redo the question as well. As I said, this question specifically number 1 comes directly from your study unit. So far in this unit we have spoken about using addition, subtraction, multiplication, division to solve an equation in one variable. We used also multiple operations, and when we learned that we have to eliminate addition, subtraction first and then multiplication, division next. We looked at equations with variables appearing many times and different sides of the equation, and we looked at equations with signs of inclusion and learned how to start those equations. Okay, for the exam, of course, when you are learning algebra for the first time, or even if you have done algebra way in the back, in the past, algebra is, as I said, is a language. If you don't practice the language, you tend to lose the skill of solving algebra. So I urge each one of you, even if you have a little bit background of algebra, you need to go over to the study units, the lessons that you have, read them, go over some examples. Hold your pen and paper and work out some problems. Do not just rely on watching the webinar or watching other videos. You have to actually do the math yourself to learn from the mistakes, or how would you organize your work so you don't get confused with the negative signs not being so clear in your writing, and so on. Also, you can watch that webinar when you have the recording before you get the exam or you attempt the exam. The practice questions, or the self-checks, or sometimes they are called the discover more questions, very important, so relevant to the exam. So it is kind of practice for you to practice those skills and get prepared to the exam. The answer keys for those questions, the practice questions, are provided to you, so you can self-assess yourself. And also, I have a handout in this webinar that suggests one resource. It is a series of instructional videos from Khan Academy along with practice questions and quizzes. So have a look at that in the handout that you have. There is like only one link that says watch and practice. You can click on that, take your time watching those videos and practicing and assessing yourself. Also, other resources that you may use to get help in this course is, of course, to call the school from 9 to 6 Eastern Time on weekdays. Also, you can go to the help center or the help and support and email your instructor. As I said at the beginning, one of the handouts that you have for this webinar shows you step by step how would you go to your portal and send an email to your instructor. Also, you're able to schedule a one-to-one appointment with a teacher, assistant, or an instructor. The link is provided in the handouts that shows you the materials of the course and where to find the reading assignments, where to find the practice questions, and so on. The link on the top middle of the page, if you click on that, you'll be able to schedule an appointment on the day that you like, on the time available for the instructor or the teacher assistant to meet with you and possibly share the screen with you and go over some problems. And that's it. Thanks for everyone who attended and asked questions and responded to the self-check questions. You will receive the recording about a day or two later. You can watch that as many times as you want. Thank you for your participation and good luck in the exam.